Hi Year 10, Lesson 5 of Adaptations and Ecosystems. Grab your notepad and pen and let's get going. So this lesson is actually probably one of those lessons that my previous students have always found one of the hardest. It's about estimating a population size. So for example, what is the coverage of grass on the school field? Or what is the population of daisies on the school field? And this is all a technique of estimating that population size. It's the next lesson we're going to be doing uses similar equipment but is a completely different style of well, it's a completely different type of practical or investigation. So try and sort of separate the two. However, they are both required practical activities. So at some point, you are most likely going to actually do this practical with your teacher when you return to school. So the piece of equipment that we're talking about is called a quadrat, and I'll show you what one of those looks like in a moment. And we're going to be sampling. So a sample is when you take a small sort of bite-sized chunk and then you use that to give yourself an idea about something else. So for example, you might get given a sample of makeup. It's in a smaller packaging and it gives you an idea of whether it's the right sort of makeup for you. Or it's like a trial of a computer game. And we're talking about population. So population is the number of an organism of a species in a given area. So I want you to have a look at this. How many daisies can you count? You've got 30 seconds. So, how did you estimate the number of daisies? First off, I wonder if you were close, but I will possibly release the number of daisies actually on that later. Hopefully you didn't cheat, by the way, as well, and pause the video, because this is all sort of a game to get you to realise why we need this technique. So lots of you probably just tried to count them all, which is probably quite difficult doing the time that I gave you. Or did you maybe use another method? Some of you maybe did things like counted a few of them and then kind of guessed, like, oh, there's a few more than that, or in the rest of the picture, for example. But I'm going to give you something to possibly give you some help. Some people find this helpful, some people don't. But again, you've got 30 seconds. How many are there? So, did you find it more useful? Was the question. Because if you were actually asked to go out onto the school field and count the number of daisies, it would probably be completely impossible or impractical. You wouldn't be able to do it. And so there's lots of different issues with that. The reason being, if it was an animal rather than a plant like a daisy, they might move into or out of the area during your counting. So, for example, if we were using a slow-moving organism such as a slug or a worm, they might have been in the area when you started counting, but crawled out of the area by the time you finished counting. So that's not really fair, is it? Some of them might die during the time it takes to complete the counting. If you're doing a really, really large area, then some of the organisms might have been alive when you started, but died by the end. You might not be able to find all the animals if it's animals instead of plants. So, for example, worms, you can't see under the ground, so you wouldn't be able to find them. So it'd be really difficult to do. And I don't know about you, but I get really confused and I would probably count things twice. So, for example, you might count the daisies more than once. So what we do is use a quadrat to sample the number of organisms in a little area, and then we kind of multiply it into an estimate of the bigger given area. And I'll show you how exactly we do that. So this is a quadrat. It's a rectangle, square-shaped sort of guide, I suppose, or frame. And quite often they are 50 centimetres by 50 centimetres. You can get a different sized one. And if you've got a 50 by 50 centimetre one, then its area is 0.25 centimetres squared. And you just do that by timesing the length by the depth. So how do we use this quadrat? So in the purple box, I'm going to sort of do the maths with you. So first off, what we just did was find the area of the quadrat by length by width or depth. So our quadrat was 25 centimetres squared. Hold on. I did a typo there. It should be 25 centimetres, not 0.25. Sorry. The second thing is to find the area of the field, which might need to be using a different piece of equipment. So you might need to go and get a trundle wheel, one of those things that you wheel on the floor and it clicks every metre. Or you might be able to do it with a meter, well, not a meter with a measuring tape. Depends on what size the area of the area you're doing is. So let's say the school field is 125 metres squared, and if we then need to be in the same units as our quadrat, it would be 12,500 centimetres squared. Then you divide the area of the field by the area of the quadrat. So basically working out how many quadrats would fit in the field. If you've got lots and lots of quadrats and you laid them all out on the field, how many would fit in that field? So you do the 12,500 divided by the 25. So we would be able to fit 500 of those quadrats in our school field. Then you need to work out a sample size. So you think about how big your field is and how many quadrats you should be able to fit in, and you kind of figure out the number of quadrats that would give you a bite-sized sample or bite-sized sort of taste of what it's like on the rest of the field. So for example, if you were able to fit 100 quadrats, then you would maybe do 10 counts of using the quadrat. If, as we were able to fit 500, you might want to do 50, but if time allows, that's quite a large number. So we're going to go with 10 for our example. So you then take your quadrat, your plastic frame, onto the field, and keeping health and safety in mind. Now, I know this doesn't sound crazy, and some of you maybe have done this in the past and enjoyed it, but you close your eyes, you turn around a few times, and then you just simply throw the quadrat onto the ground. The idea of doing that is to make sure that it's completely unbiased. So there's no sort of, oh look, there's lots of daisies, let's count those. Or I'm feeling lazy today, let's put the quadrat down where there's no daisies. You're not choosing where the quadrat goes, it's completely random. So you are unbiased. Really good keyword to try and use in your exam if they ask you why you do things like randomizing where the quadrat goes. It's to make your results unbiased. You then count how many daisies are in your quadrat and you write it down. So you literally count it. Quadrat number 1, I found 15 daisies, for example. And then you repeat by picking up your quadrat again, turning around a few times, maybe doing a few steps in a particular direction and then throwing it again. And then you repeat your count. So you say quadrat number 2, and then you count and maybe you find only 6 daisies that time. And you keep going until you've got about 10 results or more if you would like. So say you've got a set of results that look like this. So we did 10 quadrats and we've got all these different numbers of daisies inside it. So in the purple box again, I'm going to do workings with you. So you find the mean number. So just a bit of maths recap. Finding the mean is when you add all of the numbers up and you divide them by the number of quadrats we took. So in this case, we took 10 quadrats. So if we added up all of our results, we get 124, divided by 10, we get 12.4. Some people argue that you should round to the nearest whole number, so either up or down, depending on what the decimal is, because you can't have 0.4 of a daisy. But I would be careful of that, just because sometimes in exams they like you to go to 2 decimal places a lot, so I wouldn't do any rounding until the end. So keep your decimal points right until you've got your end result. You then multiply the mean number of daisies, so in our case 12.4, by how many quadrats could fit in the field. So if you refer back to our previous calculation, we found that we could get 500 quadrats in. So we would do 12.4 daisies in 500 quadrats, so times 500 quadrats, and we would get 6,200 daisies is our estimate of how many daisies are on our school field. So this looks really scary and there's lots of steps, but I promise you, when you practice it a few times, you'll realise it's actually not too bad. So let's do another one together. This is actually an exam question for 2 marks. So we've got a field, it's got an area of 6,000 metres squared, and the students used 0.25 metres squared quadrats. The students found a mean of 0.42 dandelions per quadrat. See what I mean about the decimals haven't been removed yet in even their questions, so I would recommend leaving them until the end for rounding. And they've asked you to estimate the population of dandelions on the field. So Where do we start? First off, how many quadrats will actually fit in that field? So we've got the size of the quadrat, we've got the size of the field, so we've got 6,000 divided by 0.25, so we would be able to fit 24,000 quadrats in that field. Which is a lot of quadrats, so thankfully they didn't do all of them. They did all the counts, it doesn't matter how many counts they did because they've already given you the mean, and they found 0.42, so what do we do with that? That means that if there's 0.42 dandelions per quadrant and 24,000 quadrats per field of field, we multiply those two together and we get 10,080. And that's quite simply our answer, 2 marks. You can see quite clearly where those 2 marks come from, the orange box and the purple box. You get one for calculating how many quadrats fit in the field, and then one for actually calculating the final number. If that was a decimal, that's when you would then round after that purple number. So if you've got 10,080.6, you'd then round it to 10,081. Right, so I'd like you to have a little go. Pause the video, think about the steps from the previous bit, go back if you need to, see if you can calculate how many bluebells are in the woodland. Just to give you a bit of a heads up, there is an extra step on this one, even though it's only worth 2 marks. That's because this question came from a higher paper rather than a foundation paper. And you will need to calculate the area of that field yourself. And so just be aware, obviously, that it's not just a rectangle or a square. You are going to have to break it up into 2 separate rectangles and calculate your area. So pause the video and have a little go. So for this one, how many quadrats will fit in this field? So we then actually needed to calculate the area of the field. There's an extra step on this one. So I broke it up this way. I made the field first section, the green section here, and I worked out that that must be 80 meters long by doing 150 minus the 70, so it's up to 80. And then I multiplied it by 60 to get 4,800 meters squared. I then calculated the area that is blue on the field, and I calculated that as 16,800 meters squared. Added those two together to get 21,600 meters squared. So once I've now got the area of the field, I can now calculate how many quadrats will fit in that field. So can you see how there's an extra step, and that's because this is a higher demand paper. So 21,600 divided by 0.25, which is the size of our quadrat, that field would fit 86,400 quadrats in it. So they've already done the counts, and they've calculated that the mean number of bluebells in their quadrat was 6. So just like in the previous question, what do we do now? We multiply it, so we could get, if there were 6 bluebells in every quadrat in that field, you would be able to get 518,400 bluebells. That's our answer there. So remember that this is only an estimate. It's never going to be exact. It gives us a kind of idea of how many of a particular population there are. We only use this process for estimating popular size for plants or slow moving organisms, so we wouldn't be able to do it with something like a lion because they're too quick. But plants obviously don't move, so we can count those quite easily. Slow moving because obviously they're likely to stay within the same area while we do the count, so we won't lose them from the area. So how do you calculate population size? I want you to see if you can condense all of those steps that we've just done into a really simple formula. Take your time with this. I have been purposefully mean, I apologise, sort of. But pause it, have a think, work out the order of the steps we've done, and see if you can figure out which is the best summary in terms of like a little formula of how to calculate population size. So the answer is B. You find the area that you're going to sample, divided by the total area. So basically that's the area sampled is how many quadrats you've actually done, divided by the total area. So that's working out how many quadrats fit into the total area. And then you multiply it by the number of organisms that you've counted, so your mean number of organisms per quadrat. And that was a particularly hard multiple choice one, but however, if you didn't get it right, feel free to go back through the video. I will go back onto the show my homework link, and see the BBC Bite Size webpage, where they've obviously got loads of information anyway, but maybe another way of calculating this that makes a bit more sense to you, before you have a go at the written task, or by doing the quiz and showing my homework. So our writing phase, feel free to pause the video, obviously, this is going to take you a while. So describe how to use the quadrat to estimate population size. Definitely go back through the video if you need to. Think about how we use the exam questions, and how to actually do it. Give yourself some bullet points, maybe some examples. So first, find the size of the quadrat. Second, find the size of the area of the field, or the area that you're going to sample. Find how many quadrats fit into that field, that sort of thing. That's the kind of steps I would be expecting. Grades 3 to 4, explain how the data is actually collected. So what do? You throw the quadrats, you count how many are in the quadrat, that sort of stuff. For grades 5 to 6, why is it not a great thing to do? Why is it only an estimate? What problems might you come across? And then for grades 7 to 9, why do we do it? Why might we do this sampling over a long period of time? Why might we need this data to support us, for example, maybe with an endangered species? So pause the video, write your answers, and then when you're ready, we'll go through the answers. So grab another different pen, different colour pen, another different pen, and make sure you tick it if you're right, which is hopefully the case, but if you're not sure, correct it, and always add extra details where you pick up extra marks and where you learn. So in really short steps describing how to use a quadrat, find the area of the quadrat, find the area of the field, randomly place the quadrat, count the organisms in the quadrat, repeat this, calculate a mean, and then multiply it by the number of quadrats that should fit or could fit in the field in total. So that's real brief. Hopefully you put a little bit more effort into it than that, but I didn't want to overcomplicate it for this. If you are still not sure on how to do it, go back through the video and double check all of those steps. Grades 3 to 4, you could go into more detail about how to actually collect the data, so things like counting, but the best way to actually kind of explain how to use the data is just to pop it into that formula that we discussed in the multiple choice questions. So finding the area of sample, so then the area of the quadrats that you've actually taken, dividing it by the total area of the field or the area of wherever you sample, and then multiplying that number by the number of the organisms or the mean number of organisms counted in those quadrats. Grades 5 to 6, what are the limitations? Sorry, it's only an estimate. It's never going to be exact. It's a sample. It's never perfect. But it's also not great because we can only use it for plants because they don't move, or slow moving organisms that hopefully don't disappear from the environment that we're counting. For grades 7 to 9, why do we do it over a long period of time? Why don't we periodically have a look at the sample, like the population size of a particular species? The reason we would do that is so we can actually monitor the species population. So we might be looking at protecting a particular species, maybe one that's endangered, and looking at, are the numbers improving or declining, and do we need to step in and support, or do we actually need to leave them alone now? There's lots of species that have been so well looked after that actually we don't need to worry about them anymore. Alternatively, it could be that we're trying to find out if something is actually causing a change in the population of a species. So, for example, you might want to look at whether the human activity across the field is affecting the grass coverage in the field. So you could maybe look at where you guys walk to go and find the gates on the field. Is that affecting where grass and daisies are able to live, for example? So choose your today I achieved sentence. So describe, explain, use, or combine. And what were you able to do to show that skill? So for example, today I achieved explain because I could explain how sampling can give me this estimate of population size. Up to you where you got up to based on how you got on the written task. As always, there's the show my homework quiz. Don't forget it. True or false this time, which is quite nice, a little bit easier for you. And also, if you need to go back through anything, there's the links, and go back through the video if you need to. See you next lesson.